So, hey folks, this is me, Vishwas Nair, and I'm the host of this Pioneer South India Summit. And this is organized by Bangalore chapter exclusively, and we are always collaborating with other people as well. It's always an honor to host Vivek Raja again because he's always ahead in whatever he's doing. Like he's pretty hardworking and he gives a good amount of time in preparing for sessions. And I think probably he can choose teaching as his other profession, but he's not going to do that. I know that he's going to remain a professional for a very long time. But thank you so much, Vivek Raja, for coming to this entire series. Means a lot, brother. Thank you so much for being part of this session.
Yeah, thanks for that generous introduction. Yep. Welcome everyone for today's session. And in this session, we'll be seeing about how to train and deploy our machine learning models in Azure ML. So, let's get started with that. Yeah. So, how are we going to learn today or explore this particular topic is to first understand like what is Azure ML. Then we go ahead to learn about few of the concepts and theories which is involved in it, which is necessary for it to code as well as to do the necessary training and deployment. And followed by we'll be focusing exclusively on training the models and followed by the deployment. And post that three sections, you can ask your questions. I'll be taking that through your YouTube chat. Then we will conclude with a couple of resources to be shared. So, um, so in the section one, we'll be understanding what is machine learning workflows. So the people who are not aware of what is MLOps or how that works, we'll just go a brief introduction into that. Then we will see like what are the challenges we actually undergo while doing these MLOps. Then we'll have few concepts and theories to be learned, and we are good to go. So, uh, about me, I am from Madurai and I'm working as a data scientist at Nexten. I am currently AWS Machine Learning Hero. So, that's quite amazing so far. And I'm also organizing several communities in Azure. So, I'm organizer at Azure Developer Communities in Tamil Nadu. And of course, I have very good interest in both cloud and machine learning. So, I've done a lot of certifications in cloud, which includes Microsoft Data Scientist, AI Engineer, Data Engineer, and Oracle Cloud Solutions Architect, etc. So, besides that, coming to my research part, I have published around 5 to 6 papers. Then I also filed a patent, and in my free time, I used to love to participate in hackathons, and I won a couple of them. And currently, I do speak in a lot of communities, mentoring them, as well as I write my blogs in Medium and Dev. You can do check out my Dev and Medium over there as well. So, for this prerequisite of this talk, we won't actually be. There are three things. One is to learn about you should have basic Python programming language because the whole coding section will be done in Python. And secondly, it's better to have a good understanding, like a basic understanding of machine learning, like what is what. But of course, we'll be actually learning about MLOps. Then followed by it's if you want to do a hands-on, you need an Azure account, and the Azure account comes with a free tier. But do note that spinning up virtual machines and stuff require cost. It involves cost in it, so we make sure that you don't incur any extra cost while doing this particular workshop. So let's get started. So coming to the first section, which is introduction to machine learning in Azure. So as we said, we'll be dealing on different stuff, and going with the first one is understanding. So if you try to list down the action items which you need to complete, like we need to take care of from the beginning to the end to successfully carry out a machine learning problem, it's like you need to find a data source. Then, of course, once you find data source that involves collection of the data and organizing it, followed by creating a training environment, and you have to select a machine learning model, create a training script, train the model. Once your model is trained, of course, you won't be satisfied. We need to improve the model by doing hyperparameter tuning, optimizing it. So once you have optimized your model, you have to finalize it. Okay, this is the model I have to go with. So once you have a final model ready, you have to create a deployment environment and an inference script and deploy it as it goes. So this is how an ML workflow actually looks like. And the challenges which involved in doing these is like to logically create and maintain resources. For example, like we had seen several environments, computes which had been created for doing that ML ops. So, and keeping track of machine learning experiments and while optimizing it, then also maintaining different versions of the model while training it and reusing the existing workflows. For example, you can reuse your training section and deployment section in several other projects if necessary, if you have a sort of a generalized method of doing it. So it is possible in MLOps, and uh, it's not easy to complete it or to do it in real time. So that's where we have Azure ML coming into picture that will help us to do all these stuff. So the ways to perform machine learning in Azure is like in three ways. One, using Azure Portal. So they have two UI related stuff. It's like a machine learning studio and a machine learning designer. So designer is for people who are completely UI based or who don't have much of a knowledge in programming, so they can carry out with drag and drop approaches. Whereas Studio involves both UI and plus coding, so it's like a mixed approach over there. And Azure CLI is about using CLI commands to execute every task you want. But of course, that is quite hectic to do it. So that's why people go into SDK. So my favorite is Python SDK. So we have Azure Studio to implement that Azure Python SDK. We have three things. One is Azure ML Studio, or else you can do it in Visual Studio Code with Azure ML extensions, or if you prefer to have it in other IDs, that's well and good. Once you install your Azure ML SDK, it's good to go. So the architecture, how it lies is like we have a management groups and we have several subscriptions. For example, if you create a free account in Azure, it has like a subscription which is associated with it. So a free account means you have a free subscription for it. And each subscription can have a number of resource group, and resource group are like a logical entity where you can club your resources. So it's up to you to give a name and club your resources into that. And coming to the Azure ML part of it, so everything what we call or what we do in Azure ML service as a resource is called a workspace. So every time you create a machine learning service, it's called a workspace. And a workspace is a collection of every single thing you require to complete a full-fledged project or a number of projects in that. So a workspace can have link services like data stores where you can store your data sets, and also you can have compute targets to spin up your VMs and compute for your both your inference as well as your training. And and the assets which is involved in workflow workspace are environments where you create environments for example, for training or deployment or for testing and so on so. And experiments is like each experiment is about how you deal with to get optimized results. For example, to get an optimized model, you have to do several experiments, and each experiment has several runs in it because you try to change the parameter that involves as one run and so on so. And pipelines are the automated stuff to organize and reuse those functionalities. So it's very much efficient. So we won't be actually covering that in today's session because it's quite a bit of an off topic. So if you do want to learn about it, I will refer you to pipeline session of my earlier, which I guess we have done it in Azure developer community. I would like to share that resource at the end if you like to learn about it. And points. Yep, I think the terms explains it. So as I said, I guess we had covered enough about learning about workspace and experience. It's better for us to deep dive right into the code. So this PPT will be available for you after this section. So you can come across or you can learn this particular concepts and theories later on in this particular presentation. So let's get started with training this one. So let me share my screen and right. Yep. So This notebook is actually need to be done in Azure ML. So as of now, we are not going to do it, but rather we'll just have a walkthrough of the code. And all the information necessary to set up this particular thing is given in this Python notebook. So you can just sit, relax, and walk through the code along with me. And you can use the same Python notebook in your Azure ML and implement as it goes. Yep. So our steps is to first create an Azure account with subscriptions. I hope you can do it, and create a machine learning resource. Go to your portal, create a machine learning resource, and provide a name for the workspace container. Launch your studio, and then once you go inside that, create a data set. For example, you can use an open data set and create a compute resource because that is where we are going to run our notebooks and your machine learning model. So inside that, you can now navigate to Jupyter Lab and you can run the Jupyter notebook over there. So to prepare the environments, first we need to retrieve all the necessary info and make sure we have done all the imports necessary. So this is to create a workspace in Python SDK itself. And you do need to have four information to create a workspace, which is subscription ID, which is your account subscription ID. Resource group is where you have some logical entity where you have created your machine learning resource, and workspace name and workspace region where you have to spin up that. So this spins up your to create a particular workspace and get an access to it. So workspace is equal to workspace.com config. So the config actually has these information and it can spin it up. So next one is about creating a compute. So you can do it in two ways. Either you can go ahead and in the portal, you can go to compute and create a compute resource, or you can have do it via SDK as well. So I'm going to create a CPU cluster called CPU cluster, and I'm going to create a compute target for running our machine learning models. So this will create a new compute cluster, and we are good to it. So the next one is the experiment. So an experiment is a kind of a name process where we do all necessary stuff for a project to run it. And first, let's go ahead and create an experiment. So uh, I'm going to create an experiment with the workspace, and I'm going to name it as my experiment just for a good understanding of how the experiment works. So, and whatever you do inside a particular experiment, you need to log it so that you can get back to the logs and understand where your experiment has gone wrong or in which run, so that you can rectify and keep working on that same experiment. So that's how any research process works. So this a simple experiment to show you how logging and creation of an experiment works. So we will actually be using that in training the job as well as deployment, and followed by the data. So of course, any machine learning model or problem has involvement of data in it. So we can create a data store and put our data into that. So in our prerequisite, I have told you to create a data set over there and get a particular data set. So we are going to be using diabetes data set for today's session. And I'm going to create a data store and put that particular data set inside the data store. And this, we have that sample diabetes of version 1. So since it's inside the data store. So I'm just going to print and show you what that data looks like. So these are the features, which is age, sex, BMI, BP, and there are around 6 external features, which is S1, S2, S3, S4, S5, and S6. And Y shows the level of diabetes the person has. So either you can do it in UI or you can upload your dataset from here. So if you don't have one, you can just download your diabetes dataset and upload it. So I just commented out. If you want, you can use it this as well. And you can register the dataset once it goes. So once that is done, you can start training your model. So the first things to do is to create, I'll just create an experiment to store all my experiment related files over there. So I just created an experiment here, and I'm going to create a training script. So a training script is like this is where your basic understanding of how machine learning works. So I will just leave it to you to look into the file whenever you're free. So a brief overview of this file is like you're going to do necessary inputs, and going to take a couple of arguments, which is about regularization and where's the input data, and I'm going to run the run dot get context. So every experiment has n number of runs to it, and I'm going to associate this run with an experiment workspace. So this way, I'm just going to use a simple linear regression to try and fit how it works. Then I'm going to print the log at accuracy for this particular run and see how it goes. And after that, I'm going to dump this particular model training in a folder called outputs, and you'll be able to retrieve it later. So for this particular file to run, we need the dependencies which needs to be executed for it. So let's create a dependency file which is called an environment.yml. I'm going to use these dependencies here. And the reason why I'm going to create a training script and the dependency file is to it's like we're going to run these in an compute target which we have created earlier, which is a CPU cluster. So the dependencies will be getting installed in that particular Docker image, and that will be executed. That's where your training script will be executed. So this is how it's easy to create a particular training script. So we are just going to create an environment from called experiment env, which is going to take YML file and going to install all the stuff. And the script config is a method, is a class which takes where is that source directory, which is experiment folder where we have all the files and training scripts. So this is that script entry script, and these are the arguments which I'm going to pass. So the input data is going to I'm going to refer that to the data store. I'm going to run that in compute cluster, which is as a compute target, and environment as env. So what happens when we execute this particular run is that it's going to create an environment in the CPU cluster and going to install all the dependencies. Then it will start running this particular script file and take these arguments in it, and these scripts should be available in this particular experiment folder. So let's submit this experiment run and see how it goes, and this is how the all the details of how that experiment run went. So it's about how that experiment run and is there any errors or something. If there is any error, you have to just go and change your code and rerun it, and that will count as a run too. So once your models are all ready, for example, if I've run several runs, I'm going to pick out the run and I'm going to download this file over here, and I'm going to use that. I'm going to register that model because we have just dropped it in a folder, but we need to register it to keep using it in somewhere else. So I'll take this particular model and register it in our workspace, and then I'm going to version it as model.version1 and with along with the accuracy and the regularization code in it. So we have several versions with us, and we'll be just you can use any of the models to deploy it whichever you feel so. So deploying the model, before going to that, let's hop on to come off a couple of concepts, then we'll again start with working on that. So when it comes to deploying the model, so we need three things. One is the scoring script, and second is the inference and deployment configuration. And we need to decide where we are going to deploy it. It can be in local your machine, or it can be an AML compute, or it can be Azure Kubernetes Service. So let's go with our presentation with the code sample. So the first things first is to create a scoring script. So I'm just going to create it as score diabetes.py, and it's going to take the diabetes model and load it for the prediction. So scoring script should have two methods, which is init method and run method. So init method is executed when we first launch this scoring script. So it will load all the model files and keep the environment ready for to consume that prediction data and the incoming test data, real time, whatever you say. And once it receives it, it's going to do the prediction and return the prediction data. So init is to set up all the environment, and once that is done, the run method will be executed every single time an endpoint call is made to this particular model. So first, let's do a local compute. So I'm just going to deploy it in my local machine and see how it predicts. So This is the test data. I'm going to put it as a JSON file, and the service dot run is to give that input data as that input JSON, and this will be executed over here, and we'll be predicting this model using model.predict inside run method. So these are the responses we got. So the second method is AML compute. So the difference between, yep, that's a local and this will be a cloud-based approach. And in coming to the AML compute, you don't really necessarily to take care of the number of the traffic and as well as the container instances and so on. So you can just define how many cores you want and how many GB of memory you want, and Azure will take care of everything over there. So it's just going to create as a ACI web service with 1 core and 1 GB of memory. That's enough for us. I'm going to name it as Diabetes Service 3, and I'm going to deploy our model, so which is workspace, service name, the model, the inference config, so which defines our environment for our inference, and development config. So that takes how many cores and how many necessary stuff to be there. So once the deployment is done, your service will be ready to consume real-time data, and you can print that scoring URI over here. With this, you'll be able to make a REST API call and you'll be able to get a result. So we can just see that as well. So we are going to take a test data, put it into JSON. I'm going to make a post request with this endpoint and this input data and headers as this. So this will give you the necessary output for it. So the third one is a Kubernetes cluster. So the difference between using an ACI and a Kubernetes cluster is like two ways. You can have the leverage of managing the containers, and secondly, it's more secure. So you can pass your keys only when you pass a key. You can make a prediction. So it's like securing your endpoint. So I just commented out for this particular session, but you can uncomment it and start running as well. So what all it takes is like we are going to set an AKS compute of this VM, and I'm also going to provision this provisional config, which is as we have seen. Then once your AKS cluster is ready, we are going to deploy it in the same way of workspace, service name, model, inference config, deployment configs and stuff. Once you have this coding endpoint, you can just pass it along with the key. So what I mean by key is like a key is necessary to create to pass an endpoint or to call an Kubernetes endpoint. So once that is done, you'll be able to predict it. So in this particular session, we actually saw about how to create or to understand those functionalities of how Azure ML works, and we also quickly saw about how to load the data, train the data, and deploy it. So make sure this project involves cost, so make sure that you don't incur any extra cost over here. And how you can even more improve this particular workflow is to setting up pipelines. So these are the links to the documentation, but we also talked about in other community sessions. So if you want, you can refer to that as well. And to summarize that, what you have done is we have taken a configuration notebook if you do necessary or the workspace and sort of stuff. We trained within the notebook, we trained in local compute and in remote VM as well as in Kubernetes cluster. So this is what it is. So this actually is a major junk for your Microsoft data scientist associated with this DP100. So this covers a lot of topics in that. So if you want to take up this exam, it's well and good for you if you're looking for a data scientist in Azure. And here are the links to it. So let's quickly hop back to our presentation. And this is available in my Azure ML series GitHub link. And now I'm available for Q&A.
That's awesome, bro. That's awesome. As usual, Vikas is here. Thank you so much, Vikas, for being part of this. So, how to manage the cost in Azure and also how to choose what services to use? Yeah, that's true question, man. Hundreds of services.
Yeah, so that comes with what kind of project you're working. So if it's like an industry based or for your personal work. So for personal, I guess it's better to have your own subscription and limit your expenditure on that. And we have cost management service in Azure, which tracks all your resources, what you create, and the cost associated with it. But make sure that that gets updated only after once every 1 day. So it means like I guess it gets updated every 5:30 a.m., which is 12 UTC. So 0 UTC. So make sure that you have your cost in your mind so that you don't get billed more than what you want. And also you can set up alerts and limits in your cost management so that when you run over a particular limit, it it sends out a notification to your email and an SMS that you have crossed your limitation. So you have to go and turn off your particular resource. So that's one way, and that's one half of your question. So coming to the second part is like how to choose your what kind of service to use. So that entirely depends on what you're going to execute over there. So when it comes to machine learning over here, we just need to spin up a machine learning service. And of course, we have seen about deployment. So of course, you do need to have a deployment cluster like AKS, but that can be managed over code as well. So the code which we have discussed will spin up an own AKS cluster for it. So that is where you can choose about your services and learning about which services to use where. So that's where your placement of your architecture also contributes.
Is how companies deployment scale works. Oh man.
Okay, so that's an interesting question. So it's when it comes to enterprise where we have several models running for it, and there are a huge traffic of incoming traffic for your machine learning predictions. For example, if you take a Snapchat or like that, any filters or Instagram filters, so it's like it might get a constantly and request response to manage your input of an image sort of stuff. So to think in that sort of a way to understand the deployments is to uh, spin up deployments in several regions, so that you don't incur the latency. So the first thing is the region and availability. So that's the first concern. So if your the customers are in US, it's better to spin up a service in US. Or if you have a varied customer, so try to do it in several regions. And secondly, when we have on the deployments is about the resources what you require. So you need to also have an auto scaling feature enabled so that you don't have to manually upscale it every time you have a large traffic, or to downscale it when you don't have much of it. So it's that's where your auto scaling will really help you out. And second, you have to set a base uh, before the auto scaling works. You have to just set a base like this is what is my requirement and this is what I execute, so that you can maintain a constant cost as well as you can reuse and go over a limit whenever there is a huge traffic or less traffic, respectively. So that's
Yeah,
how a deployment works in that way. And there is, of course, we have several deployment strategies like containers or in edge and so on. So to make sure
Kubernetes.
that if your model is interacting with several other models, you have to facilitate that communication, which involves your networking as well. So you
Yeah.
have to configure the network as well. So these are the considerations you have to take when you take your project to the next level of deployment. And of course, that's how companies do it as well.
Yeah, like adding on to that, like, data collection strategy matters a lot here. Like, forget the fact that you have the state of the art ML algorithm deployed. What if there is no
Yes,
data? Like, something like Snapchat has no traffic above 5 minutes probably, but a company like Hotstar or else a Netflix gets hits more than an hour by some people. Like, max will be for at least 30 minutes for sure. And you have to build a redundancy in such a way that your application is available at all the locations. So there is always a
yes,
redundancy location, like three tier locations. Like,
yes.
they're the the region of global redundancy is actually reduced on that scale. Like, it
Correct.
can be a share market wala stock exchange wala application that you're building that has a different way of traffic. So analyzing what's your traffic and architecting towards it, that's what MLOps is. Like, people say MLOps is
Okay.
all about algorithm. Sorry for that. It's also about strategy also. So yeah, and also
Yep.
Rajesh is asking something like, is it container costly for deployment models? Like, that's what he's saying.
So yeah, so it's like a trade-off between what you require and for that. So of course, any cloud service comes with a cost associated with it. So it's about how you want to trade off between the compute and the speed versus your pricing budget. So that's entirely onto that. So is it containers costly? I wouldn't say no. So it is. So make sure that you spin up a low. end containers with less config, so you'll incur less cost. You can gradually improve it as it goes, so that you'll be able to handle that much of traffic in future. So that's how you can strategically improve your pricing as well as your deployment as well.
Yeah, that's true. That's true. But containers is considerably cheap if you think of the cost of what you're thinking on other services. Of course, Azure function is almost there, but like, when you're thinking about an cloud agnostic way, containers are the best. Like if you think about
Mhm.
that, like your model will be in a container. Of course, yesterday somebody asked, I think Vikas or somebody, I don't know, like it's a model as API. That's how you make it cloud agnostic, right? Yeah. I
Yes,
think
yes.
thank you so much, Vivek Raja. Thank you so much for sharing such great insights on this
Mhm.
event. And thank you so much, brother. We'll end the
Yep.
broadcast now.